students, let's work some of the problems from Lesson 3-1, November 2 in ALEX. In the first problem, you see a table of values, and it says for each ordered pair, determine whether it is a solution to an equation. In this case, I have this equation. And the first example is -1 and 3, and I have to click yes or no. And so what I'm going to do is I'm actually going to substitute in these values into my equation. So I'm going to say 5 times -1 instead of x minus 8 times 3 equals -29. So see, I just put in the x for the x and the y for the y. And then I'm going to use my calculator here to do this. 5 times -1, I have a sticky calculator, minus 8 times 3, and see what that is. Okay, and I actually did get -29 equals -29, and so I would say yes, that definitely works. The next thing I have is -9 and -2, and so I'm going to plug that in as well. 5 times -9 instead of x minus 8 times -2. Does that equal -29? So I'm going to plug it in my calculator. 5 times -9 minus 8 times -2. And that also makes -29, and so I'm going to put yes. And then I have 0 and 4. And so I'm going to plug that in. 5 times 0 minus 8 times 4 equals -29. So this is 0 minus 32 equals -29. -32 does not equal -29, so I'm going to say no, that's not a solution. Okay, I'm not going to finish that out for time, but that's the gist of that. Okay, number 2. Let's just change colors because it makes me feel better. It says find an ordered pair x and y that is a solution to this equation. Okay, so I'm going to find, you guys could each come up with a different answer to this. I have to pick a number. I like to pick something like 0 because it makes the math super easy. And I'm going to solve for the other number that's going to go with it. Remember, I just picked out the 0. There's no mandate. You could have picked out 100. You could pick out -5. You could pick out any number you want to. And you're going to get a particular y that goes with that. Okay, 4 times 0 plus y equals 3. So I get 4 times 0 is 0. And so y equals 3. Can you see the reason why I would choose the 0 there? It just is simple math. So this is the point. It is a solution to this equation, and I just type that in. Okay, number 3. I have to graph this. Y equals 2x minus 6. In the lesson, we just learned 2 ways to do graphing. We could use the intercepts, or we could make a table. So if I wanted to do the intercepts, I would come up with a number that goes with y is 0, and the y-intercept would be 0 and a number. And if you forget which of those is which and you're kind of confused, it doesn't really matter. You're just going to plug in 0 for x and 0 for y. Okay, keeping myself straight, if I plug in 0 here, I get 2x minus 6. 6 equals 2x divided by 2, and 3 equals x. So I'm going to put in a 3 right there. That's one of my points. And then I'm going to do this other plug-in with 0 for x. Y equals 2 times 0 minus 6. So y equals 0 minus 6, or y equals -6. And now I'm ready to graph. Thankfully, you probably get a graph in ALEX, and you don't need to freehand it like I am. So 3 and 0, 1, 2, 3 and 0 is right here. And then 0 and negative 6. 1, 2, 3, 4, 5, 6 is down here. And then I'm going to connect my line. And there we go. So that's one way to graph that. What if you didn't like that method and you wanted to make a table? Well, you could. You would do something like this. And actually, it's not so very much different, because you could actually say, I did make a table. Look at this. Right? So it's almost the same thing. When you're using the x and the y intercepts, you're just making a specific choice to use zeros. But if I had wanted to, I could have chose other values. Maybe I wanted a 1, and then I would go back and plug that in. Y equals 2 times 1 minus 6. Y equals 2 minus 6, or y equals negative 4. And there would have been another point on my graph. If you want to see that, here's 1, and then 1, 2, 3, 4. There's that next point that's on that line. So can you see that there are infinitely many points on a line? And you could choose infinitely many numbers. You need to choose 2. You need 2 different points. All right, in number 4, new color, I need to graph this line, 3x plus y equals 9. Again, you can choose whichever method you want. Let's do the table, and let's choose 0 and 0 and get our intercepts and make a table. We'll just do both at the same time. So to choose 0 for x, it's going to look like this. I have 0 plus y equals 9, or y equals 9. And then if I want to plug in 0 for y, it's going to look like this. And I have my 2 points, and I'm going to graph. So 0 and 9, this might be a little bit tall here, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just make my graph a little bigger. And 3 and 0, 1, 2, 3 is right here. And then I'm going to need to connect my line. This doesn't usually work out super well. Ish. It'll be better when you do it in Alex. But that's the gist of that. Is the 5th one. Graph the line y equals 3. Okay, this is so cool. Oh, I didn't change colors. Y equals 3 is a horizontal or a vertical line. How do you remember? I do this. I say, okay, y equals 3. And y always equals 3. And so therefore, it is going to be a horizontal line that looks like this. Cool, huh? That's all there is to it. All right, number 6. We need to find the x-intercept and y-intercept of a line, and we're looking at a graph. Let's see if I can do this without taking too much time. And the line crosses here, and the line crosses here, and it looks something like this, only actually straight. So you can see that the intercepts, where x is 0, y is negative 4, and where y is 0, x is 1. So we have an intercept here, and we have an intercept here. One crosses x, and one crosses y. And that will be your answer. You may only have to put one number. If it says x-intercept, you may only have to put this number, and y-intercept, put this number. Just keep in mind that they come as pairs. All right, the next one asks for you to find the x and y-intercept if you have this equation. And then again, x and y intercepts just involve zeros, and you can plug them in. So 6 times 0 plus 2y equals negative 6. So I have 0 plus 2y equals negative 6. Divide by 2, y equals negative 3. There is my y-intercept, and then I can plug in the 0 for y. You have to do two things here. This makes 0, so I have 6x equals negative 6. X equals negative 1, and there's my x-intercept. Number 8 gives me an equation for a line, and then it wants me to find the x and the y-intercept and use them to graph. So you're going to do the same thing as the last problem, and I'm probably running out of time. So do the same thing as number 7, and then put these on the graph. And number 9 talks about linear. Is something linear? And so if I have y equals negative 4x plus 7, it is going to be linear because x and y don't have any exponents or any other crazy stuff going on. There's no x times y. If I want to put this in standard form, it's going to be like this: 4x plus y equals 7. Can you see that I added 4x to both sides? So that's the ax plus by equals c form. Y equals negative 6 is also linear. It happens to be a horizontal line. If I wanted to, I could say 0x plus y is negative 6. That's your standard form right there. So yes, this one is also y equals x is the coolest line ever. It's actually this. It's a perfect diagonal, just like that. It is linear. If I wanted to, I could say negative x plus y equals 0, or negative 1x plus 1y equals 0, and put it in standard form. But yes, that is also. And then in this case, there is only one that is not, and I can see that this is not right away because it has an x squared. And so I can't put this in standard form with an x and a y because of that. So I will just say no. That is the only one of that example that is not linear. So hope that helps. Let me know if you're having any difficulties.